All right, so I'm gonna go ahead and finish these notes here for us, and make sure you take good notes here, and also when you're doing this stuff later, you're graphing these things on Desmos, so know how to do that as well. All right, so we're going to use Desmos to graph this function, this tangent function. And first of all, notice that you can kind of rewrite this tangent function. You could write it, sorry, you could write it like this instead. You know, 0.5 doesn't change, but this tangent of x over 2. So realize that that's 1x over 2. So it's really like tangent 1/2 x, right? It's another way to write it so that the b value is very apparent, and then minus 3. Okay, so we have our a value, our b value, and then this is a vertical change, right, up and down. All right, so let's see, amplitude. So tangent graphs don't really have an amplitude, but this thing has been shrunk to 0.5, so we're going to put 0.5 there, but just realize that for later, you don't really call that its amplitude, but we're just going to note it there. There is no reflection because there is no negative in front of this problem. All right, vertical shift, yes, it has gone down 3. Okay, a phase shift, a horizontal phase shift. There's nothing like that going on here yet because there's nothing with the x. This minus 3 is after the problem, so there is none of that yet. All right, but the period change. Period change, that is significant here because the period of a tangent used to be pi. So remember these formulas that we have right here. If I have a tangent graph and the period is going to change, I take pi and divide it by the b value. So in this case, I take pi and I divide it by 1/2 because that's my b value. So that would turn into pi times 2 over 1, so that turns into 2 pi. So actually it turns into the period of sine and cosine. All right, so that's all you're going to have to do on your own. The rest of it you're going to get from Desmos. Now one thing you could notice, it's moved down 3, so you might, I like to draw like a little dotted line here because that's going to be like my new center. Okay, and let's just look at Desmos and see what we get. So 0.5 tangent x over 2 minus 3. Here we go. So 0.5 tangent and I need parentheses x over 2. Whoopsie, not there. Minus 3, right? All right. 0.5 x over 2. Yep, there it is. All right, so I'm gonna I'm gonna zoom in here a little bit so I can see what's going on a little bit better. All right, so that 0.5 made the graph a lot what would we say, a lot like shorter. Okay, I'm gonna see if I can't make this like zoom square or something. Change that a little bit. All right, there we go. And there's my zoom square popped up. All right, I like that a little bit better. All right, so there we go. So I'm just going to draw this. Let's notice the asymptotes. The asymptote has moved to pi and negative pi. Well, if you go back 1 pi and forward 1 pi, that's a space of 2 pi. So there we go. There's my asymptotes, and that's my period. So pi, and the next asymptote is at 3 pi, so let's just take note of that. So pi is the first asymptote here. The next one's at 3 pi, so it's over here. And I'll just put these first few graphs. Okay. All right, so from there, I'm just going to draw my tangent curve. It kind of comes up here, kind of flat, and goes up. And kind of comes up here, kind of flat, and goes up. And so that's basically all you're going to have to do is just kind of, you know, copy that off of Desmos. Right, so you're also going to have to know how to recognize the period of a function from a graph. If you have to be told the basic function, is it sine, cosine, or tangent, and then you can analyze a graph and find the numbers you need to build the equation. So let's do that a couple times. All right, so this is a sine function, okay? So let's analyze, first of all, let's do this. You have a sine function, and let's draw the normal sine function. Like if I try and think to myself, okay, the sine function. So the sine usually goes like this. It usually lasts till 2 pi. It touches here at pi, and then this is 0. And it goes from 1 to -1. So that's my regular sine function. And this one looks a lot different. So first of all, let's look at any kind of vertical shift, just like we did in the Desmos activity. the graph goes from 5 to -1, that's a space of 6. So if I go 3 up or 3 down from here, it puts me at the center, and there's center. So I already know how to build some of this problem. I know that this graph must have a +2 on the end because that's the new center line, right? And I know the amplitude is 1, 2, 3. So it has to have a 3 in front of it. And then I do notice it's going up and down. So there's been no reflection. So there's no reflection. All right. But it kind of looks like the sine function. It's going up and down and up, down and up. But there has been a significant period change. So we'll worry about that in a second. So the vertical shift has gone up 2. Amplitude is 1, 2, 3. So the amplitude is 3. All right. And then I have a sine. Right. And I have to figure out what to do with the period. So let's look at that period. Remember, the period is the amount of time that it takes to complete one full cycle of this graph. So if I look, it goes from here down and there. Pi over 2. It only took from 0 to pi over 2 to complete one cycle. So the period of this thing is pi over 2. But that doesn't really help me that much, except for the fact that I know the period. I have to figure out what the b value is. So let's look back at our formula. The formula for the period is 2 pi over b. So I'm going to use that to find the b value. All right? So 2 pi over b has an answer of pi over 2. Because this is the formula for the period, and I know the period is pi over 2. So let's clean this up. Let's, first of all, why don't we cross pi off? That's pi on both sides. So now I have 2 over b equals 1 over 2. So let's cross multiply. So I get b equals 4. Oh, perfect. So b equals 4. So if I put a 4 in for the b value, then I will get this problem. So first of all, let's recognize that the period was pi over 2. And so I should put a 4 right there for my b value. So if you would go to graph this on Desmos, you should see the exact same graph that you have here. And I mean, we're not going to do it because I know it's right. Okay. So, all right. So next one. This is just a good old graph. I told you that it's a cosine function. Okay. And let's see. So it's a cosine function. It looks like it's going, here's a high point, and it looks like the low point is like right here. That's the low point. So there's my center is right at -4. So if my center is at -4, this thing has been moved down 4. Okay, so I know my equation is going to have a -4 on the end. So let's think about a normal cosine graph. A normal cosine graph starts at the high point, it goes down and back through here, it comes back up and goes to there. And it takes 2 pi to do that, right? From 0 to 2 pi. All right, so let's take a look. All right, so I'm not going to be, I don't have enough of this graph, but actually look at my amplitude. My amplitude is 1, so that's fine. There's been no reflection because this pretty much looks like my original graph. The b value, oh, I'm sorry. The b value up here is 4. I put a little spot for that. So the b value, let's figure that out, and the period. So I'm going to have to look at this graph a little differently because I started here and I don't know where I'm getting back to there. But if I look at this picture, I do see these spots right here. I see this spot and I see this spot. Those are the exact same place. Do you notice that you have gone risen up and come back down to the same place? And then you're about to do it again. You're about to rise up and go back down to the same place. So that must be my period. Those 2 yellow dots contain one cycle of this graph. So the first yellow dot is at -2 pi, and the other yellow dot is at +2 pi. So I've gone 2 pi and another 2 pi, so you know what? The period is 4 pi. Okay? So if I want to figure out the b value, 2 pi over b came out to 4 pi. So I need to solve for b. All right, so first thing I'm going to do usually, always, is cross off the pi's. So now let's cross multiply. This is 4 over 1. So I'm going to get 2 equals 4b. So if I solve that, I get 2 over 4 equals b, so b must have been 1/2. So my b value, 1/2. Okay, so when I write my equation, I get y equals, and then I have, it's a cosine, the amplitude isn't changing. My b value is 1/2, so I'll just put 1/2 x right there. Or you could put x over 2. Okay, and again, you could go type that equation into Desmos and check it, but it's correct. All right, so let's do, we're going to do this again, and this time we're going to be looking at a tangent function. So I notice on this tangent function, you see how it's crossing right there? That looks like the center. So this thing seems like it's been moved up 1, all right? Let's see, I have not changed the amplitude. I've told you that here. So it's going to be y equals tangent. I'm going to leave that part blank here, but I know this is a +1 right here. So let's look at the period. So one cycle of this graph has been completed in this amount of space. So that's gone from -2 pi to +2 pi. So the period is 4 pi. That's a big increase. All right, so let's find the b value. So the period is 4 pi. So originally, tangent has a period of pi. So instead of doing 2 pi over b, I'm going to do pi over b equals 4 pi. All right, so let's cross off pi. And so basically what I have left is 1 over b equals 4, and we can put 4 over 1 if we want. So when I crisscross multiply, I get 1 equals 4b. So b must be 1/4. So there's my b value, 1/4. So basically you're going to notice that whenever the period is bigger, your b value is going to be a fraction. And when your period gets smaller, your b value is going to be a whole number, like a 5 or a 2 or a 3, something like that. All right, so I'm going to put 1/4 x, or you could put x over 4, your choice. All right, so let's get down here to the sine function. All right, so my normal sine function looks like this. It goes up, down, and up again from 2 pi, 0. And then here's pi in the middle. So I do know there's something tricky about this. Look at how this graph is going down first and then back up. There's been a reflection. So I'm going to say yes finally to that. So amplitude and my vertical shift. So this graph is equally spaced. It goes 4, -4, so the center is at 0. So the vertical shift, there has been no vertical shift. But my amplitude is 4. Okay, so I can start building an equation. So it's sine, the amplitude is 4, so 4 sine. I'm going to leave the period part blank, and there's been no vertical shift. Oh, but it's a reflection, so I need a negative. Okay, all right, so let's figure out that period stuff. So the period is the amount of the time it takes to complete one cycle. So if I look at this, go from here, back up, and down again, there's one cycle. So I completed one cycle in the amount of time of pi, or in the distance of pi. So the period is pi. So I have to find a b value that creates that period. So the normal period is 2 pi. So I'm going to take 2 pi divided by b equals pi. So what do I have to do? So let's cross off these pi's, and you might be able to tell that b is 2 right here, but let's just cross these off. So I get this problem. I get 2 over b equals 1. So you can see that b times 1, so you get b equals 2. Okay, so b must be 2. So when you write your equation, you're going to put 2x. You always have to have an x. Alrighty, so now comes for a horizontal or phase shift. This is, let me tell you, the absolute worst. Okay, so it's kind of annoying and like, because you know, shifting things left and right, it kind of gets you like off of what you're used to, but just has to be done. Okay, so we're going to really rely on Desmos to help us out here, but we're going to have to be able to tell all the different things about this graph. Okay, all right, we're on the home stretch here, last couple slides here. So horizontal phase shift, this is a sad one. I hate this one. All right, but remember that is moving you left or right, and that is this piece right inside there. Now, to do this, you have to have it totally separate to see what is going on here. So what I mean by that is this. you have a 5 right there. You have cosine. Now, do you see how this parentheses has everything in it? This 2 is like involved in there. You need to have that 2 that's in front of the x be outside of the parentheses. So you see how it has to be like this. The b has to be in front, and then the true phase shift is going to be left over right here. So I have to take 2x minus 2 pi, and I have to get the 2 out of it. Okay, so I'm going to like factor basically. So if I take a 2 out of that, what I'll have left is x minus pi, right? Because I basically am dividing both parts by 2, and so I'll have x minus pi left over. And now I can literally see that the phase shift is pi to the right. Okay, all right, so you have to get used to that. So here we go. So amplitude, 5. Reflection, nope, there's no negative. Put none, no, whatever. Vertical shift, nope, there's no plus or minus on the end, so there is none. All right, period. A period is 2 pi divided by the b value. Well, the b value is 2, so 2 pi divided by 2 is pi. Okay, and the horizontal or phase shift, so that is right here. It's moving to the right by pi units. So I'll put right pi. And so you just have to break that down and do that, and then the rest of it is literally off a Desmos. So let's go ahead and see what it looks like. Alrighty, let's see. Oh, we got 5 cosine. And you can just type in the original just in case we made a mistake. But anyway, 2x minus, and then type the letters pi. 2x minus, oh, it was 2 pi, wasn't it? And that's it. Okay, so there it is. So you see how it just is going to be looking a little bit different. It actually does look like the normal cosine graph because we shifted it enough to like make it look almost normal again. But so let's just take a look. It's at some points on here. So this one is at 0, 5. It crosses in the center here, and it's back up here at pi 5. At pi over 2, it's down at its low point. So just kind of like get that in your head. I'm going to be at 0, 5 and pi 5, and then I'm going to like do everything in between. So 0, 5 and pi 5. So 0, 5 and pi 5. That's going to be one rotation. So remember, cosine normally looks like this, and so it's going to look pretty similar. So it's going to go down in the center to -5. So I'm going to have to complete my graph in between this space, and there it goes. And then if I have to complete it within that space right there, I got another one coming at 2 pi, and then this one down here. So I draw it there. Okay, so the drawing isn't going to be as much important this year as the recognition of all these like facts about it. All right, so last one's here. So this one, this is a sine function, and we're going to want to tell all the things about it. Okay, so there's been no reflection. So normally sine looks like this. So it's like that and like that. And this right here, this graph does look like a reflection of that graph, but I've told you there's no reflection. So there's no reflection. That means that we're going to have to take our graph and shift it left or right to get it to look like that. Okay, all right, so let's take a look. Amplitude. So the center of my graph is at -3, and my graph goes above and below that by 1 unit. So my amplitude is still 1, but I have shifted downward 3 spaces. So my vertical shift is down 3. Okay. Horizontal shift, not sure yet, but let's go ahead and do the period. If I notice here, the period, the amount of time it takes to get back to where I started, is pi. All right, so let's figure out our b value. So 2 pi divided by b has to come out to pi. So that must mean that b is also 2, because 2 divided by 2 makes 1, and so the b value is 2. All right, so let's start this up. Y equals, amplitude is 1, this is a sine function, so sine, I'm going to put a 2 in front of my x. There's been a phase shift, but I have to think about that, and this thing has gone down 3. So that 2 is there because that's my b value. So let's see. Think about this. The graph normally would start here and rise up. So do you see that the normal graph should be here and rise up? So that amount of space that I have gone over from what the normal action is my phase shift. This thing has been moved to the right by pi over 2, because normally it would start in the center and go up from there. So this thing is not starting until pi over 2 later. So that right there is my horizontal shift. Okay, and it's to the right, so minus pi over 2. So like I said, these are a little bit harder, but okay. And then you could always confirm. You would graph this up in Desmos and make sure it looks like that. All right, so I know it's been 20 minutes. Let's just finish up this last one and be done. Okay. All right, here we go. So this one is a, oh, sine. No, this is a tangent function. Sorry about that. This is a no sine function. All right, no reflection. All right, amplitude. This one, there's been no amplitude change. I'm going to tell you that right now. I forgot to write that on there. Okay, so vertical shift. So there has been no vertical shift here. It looks like my center is like right in the same place, right? Like the center is shifted over to the right, but it's basically in the same place. Okay, so no vertical shift. Okay. Horizontal shift, yes. You know, normally a tangent graph looks like this, and normally it's between pi over 2 and negative pi over 2. Okay, all right, but this has been shifted over, obviously. So if I look at this, I think it's been shifted over by pi over 2 again, because it should have been at 0, and now it's over here. So it has been shifted over to the right, pi over 2. Okay, and let's take a look at the period. All right, so the period of this thing, this graph lasts all the way from, it looks like my asymptote is right here, and my next asymptote is right here. So let's figure out how wide that space is, from negative pi over 2 to positive 3 pi over 2. So that's basically 2 pi, because it's basically 1, 2, 3, 4 blocks. So if I start over here, 1, 2, 3, 4 blocks is 2 pi. So my period is 2 pi. So that's not the normal period of tangent. The normal period of tangent is pi. So I'm going to figure out what the b value was. So pi over b has come out to 2 pi. All right, so let's cross off the pi's. So I basically have 1 over b equals 2. So that means I have 2b equals 1. So b is equal to 1/2. Right, and there's our equation. So the amplitude did not change, so I just have tangent. There's no reflection. My b value is 1/2, so I'm going to put a 1/2 parentheses. I'm going to do my horizontal shift, x minus pi over 2. So if you graph that, you get this picture. And that is it. And I'll see you in class next time. And please email me or anything if you need any help with anything. Talk to you later. Bye-bye.